Hello, everybody. So this is first piece of lecture for Math 2740, which is mathematics of data science. And in this first little lecture, I'm going to give you some information about the course. So first of all, my name is Julien Reynaud. I'm a member of the faculty in the Department of Mathematics, and I will be teaching this course. This lecture, so to speak, is just organizational. So I'm going to go over details about the course. So the first thing I want to discuss is how to get in touch with me. The preferred and probably the only way that's going to work is to use email, and my email is here. It's julien.reno@manitoba.ca. I remind you that as policy at the University of Manitoba, you're supposed to use your MyU Manitoba email address. And also, I will recommend that you use tags in your email, such as the one that I indicate there in your subject, because I have a lot of work related to COVID-19. And if you want to have a chance for me to read your email, it's important that you indicate that your email is relative to the course. So please do that. Don't try phoning me. I'm typically not in my office, and even if I'm in my office, I tend not to answer phones when the name is not displayed. And lastly, about contacting me, I will be on campus very often. But until the time when the full mandate for vaccination has come into being, so it's the end of October, I will not be seeing anybody in person. So in terms of getting information about the course, the UofM website for the course is really where you will get all the information, and I will point out that it's your responsibility to check that website from time to time to make sure that I have not made announcements and such, because I will do so on that website, and I will not use mass emailing to the class unless it's really necessary. So in most cases, if you want to see information, go to UofM. That's also where the marks will be posted and anything. In terms of the lectures, so I'm recording this at the end of August, and I'm planning to continue doing so throughout the beginning of September. The lectures, therefore, are pre-recorded. I will make them available online. I am still choosing a method of delivery. I mean, they will either be on UofM or I will put them on my Google server under protection. Whatever, we will see. What's important is that in principle, all the lectures will be online relatively soon. The proper lecture times are Tuesday and Thursday, 11:30 to 12:45. My plan at this point is to connect at that time. So if people have Zoom, I have questions, so I will connect by Zoom. The info will be on UofM. And if people have questions, you're welcome to ask them at that point. I might actually change one of the two times so that people that cannot make it at the time of the lecture get an opportunity to ask me a question on another time. And anyway, as already indicated, everything about this will be posted on UofM. And if nothing works in terms of meeting me, if you cannot attend the Zoom lectures, then I encourage you to get in touch with me by email and we'll work out something. This class also has tutorials, so there's 3 different lab sections. They're all on the Wednesday, as you can see below. There's one at 8:30 to 9:20, 9:30 to 10:20, and 11:30 to 12:20. These labs, of course, are not mandatory, but it's strongly recommended that you attend them because I think in particular that's where you will review all the mathematical aspects of the course, and I will come back to that in a second. In terms of evaluations, we're still running remotely, and because of that, I'm going to use assignments only to evaluate the course. There will be 1 assignment every week, and that assignment will include a mix of mathematical and computer work. I'll come back to the fact that we will be doing computer work a little later. On assignments, I am not going to mark all questions that are asked. Okay. I will provide solutions to all the questions, but I will not mark all of them. However, if you fail to provide an answer to a question that ends up being marked, and I, of course, will not announce before the assignment is returned which questions are marked. So if you do not answer a question and that question is marked, you will get 0 on that question. Also, there will be 1 assignment every week, as I said, and I will not allow late assignments, and they will not allow makeup assignments. Okay, so if you miss a deadline, that assignment will be worth 0. On the other hand, I am allowing for a little bit of flexibility, so I will not count all the assignments. I will only count the 8 best results on assignments. So suppose you get 100% on 8 assignments, you can forego all the others. I do not recommend this, but it is feasible. Okay. Now, as I mentioned a little bit before, this course will involve some computer work because I think it's important. This is a course about data science, and if you want to become a data scientist, you will need to use computers. There's no way around it. Computers are an integral part of the job. And so I am going to require you to do some computer work. Just a word about languages, so programming languages. In data science, I would say most people use either R or Python. If you think about things, typically R comes more from a statistical point of view, and Python is more computer science in inspiration. I'll point out that there's really good value in both languages. Speaking, so to speak, both is really a plus, I believe. So I will provide some pointers as to how to use both languages. However, in terms of assignments, I am going to ask you to return your assignments in R. If you return an assignment in Python, it will not be marked. Okay, so this has to be clear. The language for the course, for the assignments in this course, are in R. I will, as much as possible, always provide the equivalent solution in Python so that those that are more drawn towards that language can see what we're talking about. But you need to use R for the solutions. And one last thing I want to mention is that what we will be doing most of the time is using Jupyter notebooks for programming. So this is something that I will explain in much more detail in later in the course. Once we start actually toying with this, I will have lectures on this, 1 or 2 lectures on using Jupyter notebooks. For now, all you need to know is that what we will do is we'll use Jupyter notebooks on czg.ca, which is a website that is available to all students at the University of Manitoba and other universities in Canada. And the advantage of this is that you will run your code online on this platform to which you have access through your student ID. And this will not require you to install anything. All you need is a web browser and the capacity sometimes to upload files. So this is what we will be using for computer work. Yes, one last word before I finish. I was not teaching last year, so this is my first course teaching online, and there will probably be some issues with videos and the like. I'll try my best to get things working relatively well, but it might be a little from time to time. I hope I managed to do something relatively usable nonetheless. Okay. So that's it. Okay, we have seen how the course is going to be organized in practice, but now I want to spend a little time explaining to you what is data science, although you probably have some ideas already. And also I really want to take a little time to explain why it is important to consider mathematics as a data scientist. Okay. So the first thing I want to do is to give you a little quote that I find amusing. It's related to what is called big data. So I heard this when I was in a hiring committee in 2012 or something like this. It's a quote that's attributed to Dan Ariely from Duke. And it goes as written here: big data is like teenage sex. Everybody talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it. So everyone claims they are doing it. And that was the feeling at the time about big data. So big data was essentially the term that was used at beginning, I shouldn't say really beginning, but that when these problems of data science started to emerge. But then after a while, the vocabulary evolved because people realized that, okay, having a lot of data was an issue, but there could also be problems where the amount of data would not be huge, but the complexity of the data would make the problems complicated. And then there was a further evolution in terminology, and we seem to have settled on this right now, and it's we now speak of data science. Okay, but data science essentially includes big data, complex data, anything data related. Okay, now, data science, what is it? I mean, going by Ariely's quote, essentially it can be a bit of everything, but this is how it's defined in Wikipedia. It's an interdisciplinary field, and that's very, very important. There are many disciplines involved in a field, and that field uses scientific methods, processes, and algorithms and systems to extract knowledge and insights from both structured and unstructured data, and apply knowledge and actionable insights from data across a broad range of application domains. So what's important here, I'm not going to go into the details of structured and unstructured data. This is something you'll probably see in computer science courses. So what we're going to focus on here is really the interdisciplinarity And if you look a little bit further in that definition, you'll see that the definition says it uses techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, information science. And there's also domain knowledge. The fact is that when you're generating data, the data corresponds to a domain. So what is called domain knowledge is that data generated, for example, from MRI is different from data generated by radio telescopes. They're large data, but they are domain specific. And so domain knowledge helps you navigate data. Now, the big thing, the reason for the emergence of data science as a field recently is that there's been what is called an explosion of information, or information deluge, data deluge. The idea is that the amount of data that we have now is without common measure to the amount of data we had before. So while data science is nothing new, okay, there's some people in statistics, for example, that will argue that data science is just stats. But the amount of data that we have to deal with is unprecedented. I'll give you a small little example. So this is my phone. It's 64 gig of RAM, which is not great these days. Probably most phones have 128 gigs of RAM, if not 256. Actually, I'm often looking for space because it's a little limited on space. So I end up having to throw away things. Now, a few years back, we were not using this. We were using this. So this is CD, not a DVD. So this came before the DVD. And this was 700 megabytes. So you'd need about 90 of those, 93, I believe, of those to make for the memory on this little phone. But more importantly, a few years back, we were not using CDs, we were using floppy disks. And so here I have an example of a floppy disk. And I don't know if you can see very well. The capacity is indicated here. It's 1.44 megabytes. Now, that used to be the standard for storing information for individuals. Industries did different already, but for individuals, this used to be the standard of storage. 1.44 megabytes goes 45,500 something times into 64 gigs. So if you wanted to store the same amount of information as on this phone, on this little diskette, using this little diskette system, you would need 45,500 of those. And just to get a sense, this thing is 3 millimeters thick. So 45,500 of those is 150 meters, which, coming from the south of France, I use rugby fields as a measure of size. This is 1.5 times the space between the goalposts on a rugby field. That's a lot of diskette for something that fits in my pocket. Okay, so you can see that there has been this transition. And the thing is that the transition happened because the data is being collected. We've increased our capacity for storage because we've increased our storage needs. And so when you look at the amount of data, for example, that's being put on YouTube every single second, it's absolutely enormous. And to make sense of that, we are resorting to what falls under the large umbrella of data science. Okay, so we've got this insane amount of data. We want to make sense of it, and we use data science for this. But I'll point out that, you know, the name has changed since Ariely made his declaration about big data. but the situation has not changed a lot. Data science is still not a very, very precise thing. It's a collection of methods more so than it is an actual field. And so there's everything. You can find all sorts of methods in there. Okay, but if I want to caricature things to the extreme, I'll say, well, I mean, still it deals with several types of things. So there's two main types of data, structured and unstructured. And as I said, we won't be spending a lot of time on the difference between this. This is more of a field of computer science. But I'll point out most of the data that we will be looking at probably will be structured. Okay. Now, there's two main branches of science that are used in data science directly. It's statistics and computer science. And there's two main types of jobs that people will have as data scientists. They can be users of data science methods, or they can be developers of the methods. Okay. Now, one thing that you haven't heard me talk about here is mathematics. So I said there's two main branches, that's in computer science, and there's two main types of jobs. But I didn't mention math. So why would you care? I'll start with a case where you don't care. So, okay, so you want to use methods of data science, and you don't really care about how and why the methods that you're using work. And you're also very tolerant of errors, because if you don't care about the how and the why, you're just sort of automatically doing things without really thinking about it. Well, you might use methods in a way that they are not intended to be used in. And well, if that's the case, you don't really care about what we're doing here. But in other cases, if you want to understand how things work, well, a lot of techniques come from mathematics, whether it's in stats or it's in theoretical computer or in computer science or theoretical computer science. The techniques, their underlying core is in mathematics. And even more importantly, so that's if you're a user who cares about understanding. But if more importantly, if you want to develop new methods, then you probably have to use some mathematics at some point. It might be under disguise, it might not be explicitly mathematics, but it is mathematics somewhere. Okay. Now, one thing that I want to point out, the course that we're going to look at here, I mean, the topics that we're going to look at here are not very deep. Okay, so there's a lot more to see. And what I'm going to be teaching you about is barely going to scratch the surface in terms of the mathematical content that underlies some approaches in data science. And what I'm going to do, essentially the program for the course, is I'm going to show you a few techniques where linear algebra comes into play. And I'm also going to show you some techniques where graph theory comes into play. And you'll see that actually the two are quite related and that there is a nice link between graph theory and linear algebra. But the idea is to show you how some of those things work. But as I said, it's going to be a sort of short introduction, and there's a lot more to see. There are other courses, whether they are in math, in stats, or in computer science, that you can take to learn more about the topics. And one last thing I want to point out is that if you're interested in data science altogether, the Faculty of Science several years ago has created what is called the Data Science Nexus, and I've included a link in the slides. And the Nexus regroups people from various departments in the faculty, but as well as people from other faculties, and has all sorts of activities. But in terms of you as undergraduate students, what's probably most important is we've started this year. We worked on it for quite some time, but now we have an undergrad program in data science in which some of you might be registered or intending to register later. There's work in progress to also make a master's program in data science, and there's also work with Asper in terms of setting up a master's of business analytics. There are also the data science nexus is in contact with industry, and so of course there's going to be opportunities for co-op or internships and so on. And also it organizes conferences, events of all sorts and so on. So if you're interested in data science, I really recommend that you take a look and try to see if some of the activities of a nexus might be of interest to you. And that's it for what the course will be about.